The following organizations have provided funding for this Into the Outdoors television series.
Hey you, come take a look at this. What might seem like a simple piece of wood to you and me is actually a world full of possibilities when you look closer. See those tiny lines and patterns? They're like nature's fingerprint telling us all about the tree's life story, how old it was, what species it is, and even how strong it is. Wood is full of secret uses just waiting to be discovered. And I think a lot of answers are hidden inside this building. Today we're going undercover to learn more about the science of wood. We're heading into the laboratory to discover why wood isn't just a material. It's a scientific wonder. So put on your lab coat and join us as we head into the outdoors. These lab coats aren't just for show. All the scientists at the lab wear them, so we'll blend right in. These are our key to unlocking the secrets of wood, and I plan to find out everything there is to know about it. We're here at the Forest Products Lab in Madison, Wisconsin, where scientists study the anatomy of wood, test its durability, and come up with new ways to use it. But before we dive into the science of wood, let's turn back the clock and learn about its history as a resource. Hi.
Hi.
Can you tell me a little bit of how we use wood?
I sure can. I'm a wood scientist. That's what I do here. I have studied all kinds of uses of wood, including how we used to use wood in the past all the way up to modern day. Even before Europeans came to this land, there were Native Americans, and in their daily lives, they used the forest. They used the forest for their homes, for their canoes, for baskets. They also were very concerned about conservation of the forest. Back when this country was built, almost everything we did came from wood. In the New England area where the ships were built early on, they ran out of trees because we use so much wood for everything. But today, because of the work that we do as wood scientists, we're able to use the whole tree and not waste any wood and reuse that material in many ways and recycle it.
So why was the Forest Products Lab created?
Well, it was created so that we could better utilize all the materials in the forest. Imagine that. We cut one tree and then we grow 3 behind it to replace. And we take that one tree and then we use it to saw it into logs to build a home. Now, we don't use all the log to saw it into lumber. Some of that is non-usable into lumber, but we can take that. We can convert that material into so many other things. So at the Forest Products Lab, we help to develop what we call composite products, which uses more of that log. So here's an example. This is called plywood. So at the turn of the century, we began to make and develop plywood. We sliced around the tree to a thin veneer, and we glued them together to make a panel. But still, we had some waste and some tree left over. So what did we do next? Well, we took those chips, those strands of wood, and we figured out how to glue them together. Again, using more and more of the tree. So this is oriented strand board. It replaced plywood in a lot of uses like floors and roofs, but that wasn't enough. We still have lumber and needed lumber. What else could we do to extend this resource and replace lumber? That's where we figured out how to actually make something that looks like a solid piece of lumber and works like that, but it's made from smaller parts of a tree. So now we're using more and more of the tree. So what we try to do is we cut a tree, we grow 3, we use the tree, all of the tree, we reuse it as many times as we can, we recycle it into other products, and finally, we return it to the earth.
Let's see if we can find some other things that are made from trees. Our first stop in the tour of the Forest Products Lab is the Center for Wood Anatomy Research. This was one of the original research groups that was started way back when the lab first opened in 1910. That's a long time to be studying wood anatomy, but what is wood anatomy?
Here, let me show you how wood is formed. Emma, do you know what each of these rings represent?
The age?
Yes, so each ring represents a season of growth. Wood is formed in a very thin layer in the outside part here, and this layer is a live layer of cells, and it's constantly producing cells towards the inside, which are wood, and towards the outside, which will become bark. And then they will stop during the fall and the winter, and then they will restart the next season. You can see those stop and go times, and those are the rings that you can count in a piece of wood. There is a significant variation in wood and wood structure. Something that you can actually see here is these two pieces of wood.
That one's really light. It feels like foam.
Yes, it's balsa. That's one of the lightest commercial woods, as opposed to this.
Wow.
You see how heavy it is? So these are completely different species that grow in different parts of the world. While balsa, for example, is a tree that grows really fast, this species, known as guayacum, is a species that grows very, very slow. So, those characteristics affect the type of wood that they make.
How can you tell the difference between all the species?
Wood is the result of millions of years of evolution. And closely related species tend to have similar wood structure or patterns as opposed to less related species. Just like you look like your mom or you look like your sibling or your dad, species that belong to the same genus tend to be similar. Genus that are closely related, they're all grouped within a family. So all the plant species are grouped in families, within families. They're grouped in genus or genera, and within genera, they are grouped by species. And that's, for example, how our collection is organized. This research wood collection is the largest historic, geographically, and taxonomically diverse research wood collection in the world.
Really? How big is the collection?
We have more than 105,000 specimens of wood, representing more than 16,000 species of woody plants.
So why is studying wood important?
Billions of people still depend on woody plants for construction material, food, medicine, climate mitigation. So woody plants and wood have a very unique social, economic, and cultural value for us as a human species.
The Center for Wood Anatomy has 3 main focuses: wood anatomy, wood biology, and forensic science. It sounds like here at the Forest Products Lab, scientists are using wood forensics to help protect our forests and even solve mysteries. How does the Forest Products Lab use forensic science?
That's an interesting question. It really depends on what kind of forensic problem we have. We have scientists here who are chemists, who are engineers. We have people with specialties in fire. So there's a lot of different expertise. And then we have botanists like us that can actually take an unknown piece of wood and based on its cellular characteristics, determine what kind of tree it came from. So one example of a recent forensic case we did was actually involving a forest fire. And these 2 specimens are actually evidence from that case. They started by sending me these 2 specimens just saying, we think that this particular tree fell over and hit a power line and started this fire. And so one of the questions was, are all the pieces of this tree that had been cut up on the ground, are these from 2 completely different kinds of tree? That's where our expertise comes in, which is to look at the cells and the patterns of wood, typically under a microscope, to determine what kind of wood it is. And we use the research wood collection to verify that identification. Well, when I ended up looking at these and looking at the wood anatomy, I found out that these are both the same species of wood called Douglas fir. But then the question forensically was, well, is this piece of Douglas fir from the same individual tree as this Douglas fir? And by using an analysis of growth rings, we were able to show that, in fact, this does not come from the same tree as this. They can't be from the same tree. And that means that this tree wasn't tall enough to start the fire.
To Does each tree have its own specific pattern?
Individual trees do have specific patterns. So we've actually developed a technology called the xylitron to be able to capture an image of wood and feed it into the computer and have the computer identify the wood. So now to use this to identify wood, put it on the surface of the wood there. And then we're going to rotate the wood. We have to get the raise vertical. So you press the identify button. And it took a couple seconds to think about it. And this is the image that you just took. This is a reference image from a different specimen from the collection. And it's convinced that it's Cedrolinga.
That's right.
And it is right, yeah.
So why is it important to know this information?
There are lots of reasons why it can be important to know this information. Every single day we use information about wood science to make good choices about how to build buildings and how to make other forest products from wood. And then forensically being able to help other people solve mysteries and problems that they have. It's one of the main reasons why the Forest Products Laboratory exists, to understand the nature of the properties of wood and how best to use wood.
These scientists are taking their knowledge of wood science and pushing the boundaries. By testing the limits of wood here in the lab, they can use it safely out in the real world. Let's check out some of the labs to see what properties they're testing. Each type of wood has its own story to tell, from towering redwoods to resilient oak. And each species of tree has unique qualities that make it useful. This is the Centennial Research Facility. Let's see what labs we can find in here. What are some of the research areas here at the Forest Products Lab?
We have quite a few research areas, and they all have very specific things that they research. So for example, we have a lab that tests the moisture and the impact that weather may have on building materials. We have a lab that specifically is dealing with nanocellulose, so tiny little fibers and things that come from wood. We also have a lab that is focused on the wood preservation to figure out how do we make wood last longer.
What are some of the things I can do here?
Oh my gosh, Emma, there are so many things you could do here. So for one, you could just visit on a tour. As a student, you might consider doing an internship where you could also get a job here that's more technical and then supporting the scientists in general just by helping them with their research experiments.
Can I get a tour?
Absolutely.
Score!
Let's go.
My job is absolutely the best because I get to set things on fire. So in the fire lab here at the Forest Products Laboratory, we evaluate fire performance, flammability, fire resistance of a variety of materials that come out of our nation's forests. Behind me is our intermediate scale horizontal furnace. We use this furnace for testing fire resistance of a variety of building materials. So what we do is we will load up a sample on top of the furnace, and it's really like a bathtub of fire. The material is instrumented with thermocouples, and that's just really a thermometer. And those thermocouples tell us how the heat is moving through the material and how quickly the char is forming in the material as well. And then after a certain amount of time, we'll take the material off and then evaluate how much char is there, how much remaining wood was protected by that char, so we can determine char rates. The char rate is how quickly a char layer forms on the outside of the solid wood. Now that char layer is really important for wood because it acts as an insulation. Okay, so you can see the char layer here. This char is this dark charcoal area of the wood. So this is what's been exposed to fire. And then you can tell that it's stopped, and the insulation protects the remaining wood. So we're looking at how quickly that char moves into the timber so that we can determine how much strength is still left of the wood that remains protected by that char layer. Our results are used in innovative ways to help engineers design fire-safe structures.
This is the car wash. It stands for the Chamber for Analytic Research on Wall Assemblies Exposed to Simulated Weather. What's unique about the car wash is that it simulates actual weather, so we can dial in different weather climates. The way we test wood in this chamber is that we build a full-scale wall with framing, insulation, sheathing, cladding, all that stuff, and then we kind of actually float the wall into the laboratory and seal it into place. And then on one side of the wall, we control the temperature and humidity, just like you would in your house. And then on the side I'm standing in now, we have things like rain, we have lamps that simulate sunlight, and we have wind, and that kind of simulates the weather that hits your wall. And then we have a whole bunch of sensors in the wall, and we look at how weather impacts that wall assembly and how moisture gets into the wall, and how it can lead to stuff like mold growth in the wall assembly, which we don't want to have happen in buildings that people live in. And the reason that's important is because people are trying to figure out how to design buildings. And they're trying to figure out, well, how much moisture gets into my house in a real rainstorm? And so we can use this chamber to look at different climate zones and come up with design recommendations. So a lot of the work we do ends up in codes and standards that help make your building safer.
So here in the Wood Protection Laboratory, we look at wood durability to understand how long wood lasts in service and how we can maximize that. So depending on the climate and where you are in the US, wood lasts anywhere from 2 to 5 years if it's untreated. And as a building material, that's not good because the wood can look perfectly sound, but if you step on it, you're going through. And you know, that's a safety issue, and that's one of the big ones. So when we're talking about pressure treatment of wood, what I'm talking about is basically a bundle of wood is taken and placed into a large pressurized cylinder. You pull an initial vacuum that opens up the wood cells to accept treatment. The cylinder gets flooded with a solution containing wood preservatives, and then that is pressurized, and the pressure helps to drive the preservative into the wood cellular structure. And then all the liquid is removed from the cylinder, and then we run a final vacuum. The final vacuum is to remove excess preservatives. That helps lighten up the wood and also makes it less messy. Wood preservatives typically help to prevent attack by decay fungi and also termites.
Each fungus is different, so they all look different, and they all do different things. There are fungi that attack lumber. So we do this research to understand how the fungus is making the wood crumble and fall apart. That way we can better inform the treatments to protect the wood so this doesn't happen.
Termites live on wood as their food source. Like how does certain wood species inhibit termite feeding or other types of degradation mechanisms? And if we can figure that out in more specific ways, then we can rely on less broad spectrum type of insecticides or other things, because we can kind of utilize our knowledge to develop more targeted protection against these organisms. So that's obviously important for the environment and for human health too.
Our role here in the Engineering Mechanics and Remote Sensor Lab is to provide mechanical testing services to support our scientists and researchers. So we do all kinds of testing in here. We love to break stuff. We do what we might call a simple bending test, or we might also do some compression, actually some tension where we actually pulling on stuff, or shearing where we're trying to separate it into pieces, or maybe even some torsion testing, but we develop the engineering properties here in this lab. The reason why we do this is ultimately for safety purposes and stuff. As we design and redesign buildings, and whether it's a residential or commercial building, it would be great to know exactly what the strength properties are in the material before you put them in the building. The test that we have behind me is a simple beam test.
As bridges age, their condition deteriorates. So this is a structural test setup. It's quite interesting to find out where any deterioration would be. We usually assess that before we test it. The first thing I'll point out is the load actuator, and it has a load capacity of about 110,000 pounds. And here's the loading point, and we're measuring the deflection at the midspan of this beam. The beam's going to fail likely in this area. And for this one, I think we're expecting 4 to 5 inches and maybe 20,000 pounds to failure. But that's, again, a guess. It can be quite different than that depending on the quality of the wood and the amount of internal deterioration that we can't really see. Okay. So this kind of information will help engineers in the future to make bridges safer.
So this is a 2x4 that we're testing and bending. This is the type that would be used in a house to support the floor, support the roof.
And here is the amount of pounds we're looking at, and this is how far it's going to dip before it breaks. Those are two important things to note when doing a specimen.
You can feel it peeling a little bit in the center.
And that is the end of the test. And it took just under 3,000 pounds to do that.
So, why does this research change the way we use wood as a resource?
What our research allows us to do is explore all of the different ways that we can use all of the tree. Things that used to be thought of as just waste can now be used, whether it's lignin or cellulose or the actual wood as timber. And I'll bet there are some things that we use wood in that you wouldn't even recognize as wood. Emma, thank you for joining us today, and come back anytime.
Oh, I will. Thanks. Bye. Shh! There's definitely a lot more to see here. We need to check this out. Come on. Hi.
Hi,
So, what do you know about nanotechnology?
you got the right person. Let me show you something. Nanotechnology is dealing with the materials with a very, very small scale.
How does it relate to wood?
Well, wood, if you look at, is natural materials, but we always can make the materials smaller.
So, people earlier mentioned lignin. What is that?
If you look at the tree, there's three major components: cellulose, hemicellulose, lignin. Lignin is actually natural binder to hold the cellulose, the fibers together to make tree, to make tree stronger. So now this is the lignin. So we use this one so we can turn into these products. Now this is what we call lignin bread. What do you feel about it?
It's pretty light.
It's pretty light. It's porous. Another application we can use is for good insulation, right? To replace these materials. Now, this is current market products, structure insulation panel. Did you know what's inside the middle of the materials?
Styrofoam.
Yeah, styrofoam. Is the styrofoam good for the environment?
No.
No, why not? It cannot decompose, right? But now, if we're using naturally growing materials, coming from tree to replace petroleum-based materials, then we can develop sustainable products using sustainable materials. That's exactly what we're doing here.
Hi, what are you doing?
Oh, hi. I'm working on using nanocellulose for packaging.
What's nanocellulose?
So cellulose nanomaterials are very small particles of cellulose which comes from wood. And we start with a sawdust like this. We grind the material up so finely that we have nanocrystals or nanofibers. Take a look at this. So this is 100% nanomaterials.
Feels like plastic.
Right. We are hoping to make new packaging using wood, and this would be an example, the tray with a lid on top, and then we would have a fully biodegradable product. Ron's working on coating papers with cellulose nanomaterials. Maybe you want to check it out.
Oh, hi, Emma. It's nice to see you.
What are you doing?
I'm working on nanocellulose coatings for packaging applications.
So I think you saw a film before that's made from nanocellulose, and not only is it cool that it's transparent wood, but these are good barriers to things like oxygen, grease, air, other chemicals, smells. So those things are all important for keeping food fresh. And so one of the things that I'm doing is I'm looking at the grease resistance of these coatings on papers. And so what we do is we put a drop of oil, and so when we put this drop on there, and if we wipe it off, you see that it makes a big giant stain. But on this coated paper, so this is just a similar piece of paper with some nanocellulose coated on it. So we put a drop of grease on there, and then we wipe it off. You can see it doesn't leave a stain like it did on the other one. It just kind of wipes off. We're really excited about using these wood-based nanomaterials for packaging applications. And we hope that someday we can replace plastic.
There you have it. Case closed. Wood is an amazing renewable resource that can be used in so many different ways. From keeping us safe in our homes to helping us solve crimes. It's used in products we use every day, and that list is growing all the time. With nanotechnology on the rise, who knows what amazing uses for wood we'll discover. For now, our message is adjourned, but keep your eyes peeled for forest products in your own home. And make sure to thank your local trees next time you head into the outdoors!
The following organizations have provided funding for this Into the Outdoors television series.